I saw.
So do you have any doubts? Any topic, any
So I'm
questions?
still doing. I mean, I've solved my doubts. So
You don't have any doubts?
no, so I mean, I'm still doing.
Okay, okay. So tell me, what do you want to do? Because you have only joined. Hardik still has not joined.
So I can revise on my own. Then I'll come back if like someone joins.
Okay.
Okay. So should I leave, sir?
Hey, just wait, just wait. Wait.
Okay.
I'm sharing the screen, okay, with you. Can you see the screen?
Yes, sir.
So this is the doubt of Hardik. But let's see if you can help him. Okay. While revising, if you get any doubts, you ask me, okay? Tomorrow your
Yes, sir. I
exam.
also solved like Hardik's doubt yesterday when about the electricity one.
Tomorrow your exam
So
is early in the morning, 9 to 10:15. Okay.
yes, sir.
Yeah.
So that's how you solve it, right? Like what I sent you.
Just wait. Okay, let us discuss this problem. So question number 6.
Six. Which part?
State Kirchhoff's first law. So that you can give na, sum of
Yes,
currents
yes.
into a junction equal to
Entering
sum
a
of current
particular junction equals to
out
the
of
sum
the
of
same
current.
junction. Okay. So
Yep.
all the different chapters. Okay, some definitions you remember. Okay,
Yep.
definitions you remember like this. Kirchhoff's law is important, and the first law, second law, okay, or loop law also it is called.
Hmm.
So those definitions will carry say 5-10 marks. Okay, 5 to 10 marks in the whole
Yes, sir.
paper. And the different formulas from the different chapters and what does each formula represent. Okay, that is important. So even if you
Yes,
don't
sir.
know any question, if you write the formula related to that, you will get some marks for that. Okay, and
Yeah.
this formula sheet is given at the beginning, but they don't give all the formulas. Okay, and
Yes.
when you are doing any question, try to convert everything into SI units, so you should not make mistake in that. Okay,
Okay.
like if it is in millimeters, so you have to convert that into meters. Okay, so
Yep.
multiply by 10 to the power minus 3. Okay.
Yep, sir.
Second part they are asking, Kirchhoff's first law is linked to conservation of certain quantity.
Charge.
This quantity, so that is charge. Okay, so the current is flowing, the current multiplied by time, that is the charge. Okay, so you can say that.
So you want me to do this question?
Okay, try the first part. This
Okay, 1 second.
a battery of electromotive force 8 volts, an internal resistance 2 ohm is connected to a resistor X and wire Y. Okay. So 8 volt battery is there. It has the internal resistance 2 ohms. Current flowing is shown as 2.5 amperes, 15 ohm for the X resistor. This is a wire which is having resistor RY. Okay. So resistance X is 15 ohms. Resistance of Y is RY. The current in the battery is 2.5 ampere. Calculate the thermal energy dissipated in the battery in a time of 5 minutes. So how will you find it out?
So 1 second, I'm just getting my calculator.
Okay. So how will you find out the thermal energy in the dissipated in the battery in a time of 5 minutes? So energy we have to find out. Okay. Hmm. Okay.
So 1 second, hold on. I'm so sorry, but I can't find my calculator.
Okay. So if you forget your calculator, how will you do?
No, I mean I won't forget my calculator. I just can't. Oh wait, never mind. I found it. I found it. I found it. 1 second. Okay, let me. I'll just solve it now. 1 second. I'll just
Okay.
read the question. So I got 3800 joules.
Hmm. So energy we have to find out. Okay. So first of all, power we will find out. Na? Formula I square RT. I square R.
Yeah.
Then power multiplied by time is the work done or the energy.
Yeah.
So I is given to you 2.5 ampere, that is going this direction. Same current will flow through the battery. I am taking 2.5, it's a square into R. R we will take the internal resistance of the that battery. Okay, that R
Yes,
we
sir.
will take and multiplied with the time. Time is given in minutes. So convert everything into SI units. So 5 into 60. So it will be in second.
Yeah.
So 3800 joule is the correct answer. Very good. Now the terminal potential difference of the battery. Can you find it out?
Yeah. 1 second.
Uh, what will be the potential difference across the battery? So which formula you will use?
Um, 1 second. Potential difference, right? One
Hmm.
second, sir. So can you scroll down to the question once again? The potential difference of the battery. Okay. Terminal potential.
Come on, this is very simple. What formula you will use?
I am not sure, sir. Wait, wait, sir. Um,
Voltage across this we have to find out, na voltage V. So we know the EMF of the battery 8 volts, and this resistance we know, internal resistance, and this current also we know. So which formula we will use? We will use this formula, V equal to E minus IR. Okay, there is a formula, this see here.
yeah.
Yeah, directly done it. Okay, the formula is something like this. Okay.
Oh, right, sir. Okay, got it. I got it. 1 second. So,
Hmm. See here, this is the formula.
2 into 2.5.
See here. This is the formula, na? V equal to E minus IR. E
So I
minus,
forgot that. Okay, my
don't
bad.
forget the formula. V equal to E minus IR. So
So
V is
there are
the
so many.
voltage. So V equal to E is the EMF. EMF is
Yeah,
8
yeah.
volts minus I.
It.
I is
Yeah.
2.5 amperes. R is the small r is the internal resistance. So this is how much?
Yeah.
8 minus 2.5 into 2 is how much? 5. 8 minus 5 is
Yeah.
how much? 3. It will be 3
Got
volts.
it.
3 volts. Okay.
Got it.
Hmm.
Yeah.
So simple. Okay, let's move to the next part. I'm scrolling down.
So
Hmm. Determine the resistance Ry.
wait, I can't see you. Okay, yeah.
Determine resistance Ry. This resistance in the circuit. Suppose you have to find out this resistance. So can you find it out? Think.
Oh, okay, yeah, sorry.
Hmm. This resistance of the wire you have to find out. So can you
Can you
find it?
go up to the?
Hmm.
Can you go up to the circuit?
This is the circuit. So such questions you can expect in tomorrow's exam. Okay. Such questions will be there.
Yeah.
Also tomorrow also my invigilation is also there in the afternoon. Okay. One.
So, what's up?
My invigilation duty is there tomorrow. So I will be also coming to school tomorrow.
So you won't be there.
From 1 p.m. in the afternoon. But your exam is in the morning. So let's see
So
also.
I
I will also try
to
to come.
11:50.
Yeah, 9 to 10:15 you have exam. Morning session.
9 to 10:15. Oh,
See the schedule. I think it is 9. Check the schedule.
dang it. Physics structured 9. Yeah, 9 to 10.
Uh, so let's see also. I will also try to come. Okay, at least I am not the invigilator. Kanchan madam is your invigilator tomorrow. Okay.
Who's the invigilator tomorrow?
Kanchan ma'am is there, na? Your A2 class teacher. Business studies teacher is there. Okay. But let's see. I will also try to come. Okay, and in case you people have any doubts, okay, let's see.
Yeah, okay, sir. So once again, I'm just doing it. Hold on.
Yeah. The resistance of the wire you have to find out, Ry. So how will you find out? I have sent the notes also for yesterday's class, and I have uploaded the
Yes, sir.
session in YouTube also. You can check. Okay. For the ones
1 second.
that missed the class and they can go to the video.
Yeah, so 1 minute. 6.
6 ohm.
6.
Okay, let me check. है ना? No, it is 1.3 ohms. See here. He is getting 1.3 and he has checked it also. So
Oh,
from
one. I just saw that.
yeah. So wait, I'm solving it.
Got it. Oh, okay. No, so I realized my.
Hmm.
It's okay. I understood.
So how much voltage is coming across this one that we have calculated? That V was coming as 3 volts. Okay. Okay. So this 15 ohm and this wire, they are in the parallel. All right. So same voltage will appear across them. So see, this 3 volt will appear across this 15 ohm resistor also. Okay. 3 volts will appear across this. And we know that V equal to what? IR. Current into the resistance. Okay. So 3 equal to I. What I is flowing through this branch, we don't know. Okay. So this total current, that is 2.5 amperes. All right. So this current gets divided. It is in parallel. Suppose I current flows through this one, and say some another, say I1 current flows to the another resistor RY. Okay. So V equal to I, yeah. So same voltage 3 volts will appear across 15 ohm resistor and this RY resistor. Okay. Same voltage will appear. So 3 equal to I into R. How much is the resistance? That is 5. So from here I can get the value of I. I is coming as 3 by 15. 3 by 15. So that is nothing but 1 by 3. And that means how much? 0.33 amperes. Okay.
Yeah.
So 0.33 amperes will flow across this branch. Okay. Across this branch. 0.33 amperes. Okay. And total current was coming how much? 2.5. So out of 2.5, 0.33 has flown in this branch. So across this branch, I1 will be how much? That will be 2.5 minus 0.33. Subtract it and tell me how much it is coming. 2.5 minus 33. How much current is there?
2.17.
2.17. Okay. So this 2.17 ampere is flowing across this branch. Okay. So same current,
Yeah.
2.17 ohm, will flow through this wire also. Okay. Now again we will use the Ohm's law. Okay. We know the voltage across this RY. And that is how much? That is 3 volts. So V equal to IR, we will apply Ohm's law. V equal to IR. So voltage is 3 volts. That is equal to I. I is how much? 2.17. Into how much is the resistance? Resistance for this wire is RY, which we have to find out. So now RY we can find out easily by dividing 3 by 2.17. Divide this and tell me how much it is coming. 3 divided by 2.17. So whatever comes, that much ohms, that will be the resistance RY. Okay. So 3 divided by
1.38.
2.2.17 is how much? 1.38, है ना? So we can round it off to say 1.4 something, okay? Two significant
Yeah.
figures. So resistance will be coming as 1.4 ohms. Okay?
What do you usually have to take?
Ah. So two significant figures you have to take, okay? Otherwise they'll deduct 1 marks for that. Simple thing. Okay? Okay. Now this part he has made the mistake, Hardik. So he is not here now, but I will send him this. Okay. Now see what is. Now let me answer. Okay, you just hear the things. Okay. So a new wire Z has the same length but less resistance than wire Y. Okay, so they are using some new wire. Okay, which is having the same length but less resistance than the wire Y. Okay.
Hmm.
Now first part they are asking, state two possible difference between wire Z and Y that would separately cause wire to have less resistance than wire Y. So that they are asking the reason for that. Okay, that why
Hmm.
the Z is having less resistance than Y. Okay, provided they are of the same material. Okay, so what do you think?
Wait. So it's nowhere.
It's nowhere.
It could be talking about the density of the
Do you remember the formula connecting the resistance, resistivity, length, and area of cross section?
resistivity to.
How does the resistance of a wire depends on the length, resistivity of the wire, area of cross section? Is there a formula connecting that?
Yeah, that's
Do you remember that?
sort of. Um, uh, yeah, no, resistivity is equal to rho length, rho into length,
Uh,
cross section area.
resistance R is equal to rho resistivity into length upon area of cross section. Okay.
Cross section area.
So they're saying that Z is having a less resistance. Okay. But they're saying that they're taking the same length. So length is
Yeah.
constant. Okay. So we cannot do anything with that. So for a resistance to be less, what the two differences can be? That the resistivity is smaller. Okay.
Density and area.
Resistivity is smaller. So he has lost the marks in that. है ना? Later on he has written the correct one, that is smaller resistivity. So if resistivity decreases, resistivity is directly proportional to the resistance. So resistance will also decrease. Okay. And then resistance is inversely proportional to the area. So in order to have a lesser resistance, what should happen? The area of cross section should increase. Okay. Area of cross
Area.
section should increase. That means we should have a, suppose initial wire was like this. Now we will have a thicker wire. We will use a thicker wire. So thicker wire will have a more area of cross section. So the resistance will be lesser. Okay. So large cross sectional area. Okay. So these are the 2 points you have to write down. All right. Hmm.
Yeah, so
Now the second part which in which he has made the mistake, we will discuss that. The wire Y is replaced in the circuit by the wire Z. Okay. Now instead of the wire Y, we are using the wire Z. Okay. By considering the current in the battery, state and explain the effect of changing the wire on the total power produced by the battery. Hmm. So what will be the effect of the total power produced by the battery? They are asking.
why is replacing the current? Okay, 1 second. By considering
Hmm.
explain and the fact of changing.
What will happen to the power of the battery? Okay. So what do you think?
One, I'm just reading why.
So just why we are
Yeah.
replacing it with Z,
So
so we are asking the effect of the power on the battery. Okay.
Changing the wire. Oh, uh, why? One second, 1 second. I'm still reading.
Uh,
Is why the current Z? Okay, why Z? Why has less resistance. So
wire Z has less resistance. है ना?
1 second, sir. Power is E.
So
All right.
see, you don't have to calculate. It's a theoretical question. Okay, just you have to
I
answer.
know.
Uh,
Thing is, you can like the formula connects the
uh. See here. This
other
Ry we
way.
are representing and we are replacing it with Z, which is having a lesser resistance. Okay, which is having a lesser resistance. So see what will happen here is that these two resistors they are in the parallel. Okay, they are in the parallel. So in parallel, how we find out the resistance? We take like this, 1 by R total is equal to 1 by R1 plus 1 by R2.
Okay.
We do like this.
So
We do like this. So it is something like this. Okay, parallel.
oh,
So
so
what
the
is, uh,
moon is less,
hmm.
the current would increase.
So this, yeah.
Therefore,
So if I'm taking a lesser resistance, okay, if I'm taking a lesser resistance, what will be the effect? This total resistance is going to decrease little bit. Okay. So if the resistance decreases, this current bill is going to increase. Okay.
yeah,
This current will be say instead of 2.5, it will be 2.7 something. Okay. So if the current increases, then what will happen? If the current increases, okay. So what will happen? This voltage appearing across the battery, that is V equal to E minus IR. Okay. IR. Okay. So E remains the same. This is 8 volts. But since the current is increasing, that is how much? Say 2.7 something. Okay. Instead of 2.5 amperes, say I'm taking 2.7 amperes. And this internal resistance remains the same. So what will happen? The voltage appearing across the battery is going to decrease. Okay. So for this case, it will be how much? It will be 2.7 into 2, that is 5.4. So it is now how much? It is 8 minus 5.4, that is 2.6 volts. Okay. So now the voltage is 2.4 volts. Okay. Appearing across the battery. So now the power will become what? Power is nothing but power is equal to V into I. Okay. So since what has happened? Voltage has decreased. Okay. And the current has increased, say 2.7. So we can find out the power now. What is the new power? 2.4 into 2.7. It is 6.48 watts. 6.48 watts. And initially, how much was the power initially? Initially, power was V into I. V was how much? 3 volts. And I is how much? 2.5. Okay. 2.5. So this is how much? 3 into 2.5. That is how much? That is 7.5 watts. Okay. So initial power was more and now the power is lesser. So power is going to decrease. Okay. Power is going to decrease.
yeah,
Are you getting this? Power will decrease because the voltage across the battery is going to decrease as the current
decrease.
and as the current is increasing why? Because the resistance has decreased. And so something like this will happen and power will decrease. Okay, power decreases. Power decreases. Okay. Okay, so I will send all these notes in the group. You can again go through that. Okay, so try to solve more problems.
Yes, and
Okay, try to solve more problems so you can expect such questions in your exam tomorrow. Okay, and all the definitions you remember, and all the
Yes, sir.
formulas, their meaning. Okay, you should not make mistake in that. Okay, convert everything into SI unit. Okay,
Yeah,
I will also try to come tomorrow, okay, in the morning. So if you have any doubts, maybe let's see, I'll try to help. Okay.
yeah.
Okay, so I'm ending today's
Sir,
session.
bye, sir.
Do the
So,
revision.
what will be at school?
Huh? What?
What time you will be at school
I
tomorrow?
will, I will also try to come in the morning, okay, because your exam is in the morning. Even though my work will start in the afternoon, but I will be there. I will bring my laptop, do my some
Okay.
work, okay, in the lab. Okay, I will sit. In case if you have any doubts, you can
All right.
call them. Okay. So, chalo, take care. Best of
Sir.
luck for tomorrow's exam.
Thank you, sir. Bye.
Take care. Bye.